Hi everyone, this is Mrs. Lee. We're going to be doing the second part of the missing link right here. So this is lesson 4, the missing link. Ooh, that kind of turned out weird. So we're going to be completing the square today. So completing the square and also doing the vertex form, which leads me to the learning targets. Okay, so again, it's going to be the second and the fourth one. Well, kind of the last bit of the third one too, but rewrite quadratic equations in the form of the form x squared plus bx in vertex form by completing the square. Okay. And the second one is going to be demonstrate the reasoning behind the method of completing the square and use the method to determine the roots of the quadratic equations of the form ax squared plus bx plus c. So if you remember from last unit, I said, okay, there's going to be a time where we're going to be able to find the what's called the roots, no matter what they are, right? And so the one way we found from yesterday was by factoring, right? And the question then today is, well, what if you can't factor it? Then what, right? So here we go. So this is going to be on page 164, 4.3, completing the square, this activity right here. So the question is, if you cannot factor a quadratic function, does that mean that it does not have any zeros? And well, yeah, it would still have zeros. And we took this function right here and we graphed it. We took that equation and graphed it, and it was still, yep, right here at negative 8.606 and at negative 1.394, we still had those roots. They weren't like nice roots, like they weren't like a whole number like -8, but it was definitely a root, okay, because it does cross the x-axis, right? And we found that a vertex is going to be -5, -13. I want you guys to put that in your brain. So where did we get all this numbers? That was from Desmos. We just went to Desmos and we put those in and we found those roots. Okay, so if you have not done this already, or if you weren't able to do it in class, stop right now, put it in Desmos and see if you can figure it out, okay? And make sure you're getting these points right here of what we got, okay? Just so that you can make sure that you know how to use Desmos, okay? You don't want the test to be the first time you're using a Desmos, okay? We're using Desmos. Okay, that shouldn't be the first time. Okay, and then so what we had tried initially before we graphed the stuff was we were like, well, let's see if we can factor it. Maybe we can, right? And so we were like, okay, we know that this is 1, 1 because the coefficient here is 1. And then we're going to ask ourselves, what two numbers, when we multiply it, multiplies to 12, but adds up to 10? So the first numbers that we thought about was 2 and 6. Okay, when we multiply it, multiplies to 12, but when we add it or subtract it, we get either 8 or 4. Okay, so that's not 10. So what about 3 and 4, right? They multiply to 12, but when we add them, the biggest number we can get is 7, so that doesn't work. What about 1 and 12, right? And if we add them, it's going to be 13. That's too big. And if we subtract them, they're going to be 12 minus 1. It's 11. So the smallest number we can get is 11, and that's not 10. It's close to 10, but it's not 10. So there are no numbers that we could choose that would multiply to 12 and add up to a 10. Okay, so that's why we say this is not factorable. All right, so then we're going to go to the next page here. And the next page on number 2. And if you notice right here, this rectangle. Okay, and it says the expression x squared plus 10x can be represented geometrically as shown. Write the area of each rectangle within the diagram, which is what we did. So we're like, okay, we know the x squared is here and the 10x is here, right? And I represented them by using those colors. So this is the x squared, right? And green. This is going to be my 10x. Okay, so that's the area for this expression x squared plus 10x. All right, and the way we got this, is like what we did yesterday with the GCF, right? So if we factor out an x, right, it's literally like the length times the width, right? X times x plus 10, right? And so we know that the sides are not the same, so it's definitely going to be a rectangle. Okay, so we just made this is a rectangle. But the question is, well, can we make this area into a square, right? So, and then what we know about a square is that it has to have the same side. So whatever the bottom is, the top has to be that as well. Or I should say the length and the width have to be the same, right? So here we go. So what we did here was, instead of the 10x, we're going to split that up into 2, okay? So we're going to put 5x here and 5x here. So here we have 5x and here we have 5x, okay? We split up into 2 so that, right? So that the length of this would now be 5. So it'd be x plus 5, and this would also be x plus 5, right? Knowing that, x plus 5 and x plus 5, now we know that we have a square because the length and the width are exactly the same, right? The only thing is that we're missing this part of this square here, right? So what is this area right here that we're missing, right? And then so we're like, okay, we know how to get that area, right? And that's gonna be 5 times 5, right? And so the missing part is 25. So this is what we're gonna write. We know that the area of this whole square is x plus 5 times x plus 5, aka x plus 5 squared, right? That's why we put in the square, because it makes a square, right? Now we're gonna just have to, this x plus 5 squared is this whole square right here. But we don't want the whole square. We want to take out this, the 25, because that part is actually not included in this, the rectangle. We never had that as part of an area, right? So we're going to take that part out. Well, we know that that's 25. So we're going to just subtract out that 25. So that's what this part is right here, is that taking out, right? We literally take out that 25 from there so that we know that, so that's the area that represents this x squared plus 10x. Everybody okay so far? All right. And so over here on the right, I just showed the class. Let's see if they're actually equal to each other, because we're saying that they are, right? But let's see if they actually are algebraically. So x squared plus 10x is equal to x plus 5 squared minus 25. That's this guy right here. We're saying this guy that represents this area should represent this area, which it should. Do you see the colors where they're represented? Okay, so let's find out. So remember, we just split up the x squared, x plus 5 times it by, x plus 5, right? Do two times. And we're going to distribute it. So x times x is x squared. X times 5 is 5x. Doing this, 5 times x right here. And 5 times 5 is the plus 25. Do not forget this minus 25 right here. Let me use orange. So this minus 25 is right here, which is also right here, okay? So you can't forget to put that on at the end, because that's what we had said it was gonna be, right? And then if you notice right here, x squared is just gonna be x squared. 5x plus 5x, that's 10x. And then this 25, we're gonna take it, remember we said we're gonna take out that 25, because this, when we find the area of that, it actually includes that in there, so we need to take it out. So that's what that is. And it, look, if you see right there, it does cancel it out, okay? So just cancel out. So yep, they are exactly the same. Look, same, okay? Proof. All right, so now we're going to go on. So go to the next page, and then we're gonna go to the bottom part, so number 4, okay? So we're gonna try these guys out. So the first one we had actually, watch this first, okay? So x squared plus 8x. So we did the exact same thing as they did in the previous page, right? And so this is my x squared, 8x right here, and here's my x squared. And what we're going to do is we're going to try to complete the square, okay? So again, we're taking that 8x and we're going to divide it into 2, okay? 2 parts, right? 2 equal parts, not like 2 and 6, right? We want equal parts because remember, we want to make a square, right? So we're always dividing that by 2. So notice this green part right here is going to be divided into those parts right here. I'm going to look at the x squared right here is this x squared right here. So that part is the same. The only thing we need to take out is that little square part, because that actually is not part of the area. Okay? That has nothing to do with it. So we're going to set this up right here. So this is, to find this area, the whole thing, it's going to be x plus 4 times x plus 4, right? We're getting that 4 from this side right here, the 4x. So that's why we wrote down the x plus 4 squared. That's the area of this whole thing. But now remember, we don't want the whole thing. We want to take out that little square part, right? Which we know is 16. And how do we know that? Yeah, like we go 4 times 4, right? Just like a multiplication table. But it's like just the area, right? This is 4 and that's 4. So that's going to be 16. So we got to actually subtract that out. So minus 16. So far, okay? So we're saying that these two are the same thing, equal each other. All right. So now we're going to try this. What about we do something a little bit harder? We go x squared plus 5x. So I'm going to just draw a picture right here. Here's my x squared. Here's my 5x. Remember, we want to now change it into a rectangle, a square. This is my x squared. Now remember how we got from the 8 to the 4, right? We just broke it in half, 4 plus 4. Well, what about the 5, right? That doesn't go in evenly, right? But 5 and 5, if we take 5 and break it in half, right? So we divide it by 2, what's it going to be? 2.5x, yep, 2.5x, exactly like that, 0.5x. So this length right here is going to be x times x, right? That's how we get x squared. And this right here is going to be 2.5. because it's gonna be 2.5 times x will give us this area right here. Same thing with this one up here. We already have this part as x, so this has to be, this length right here has to be 2.5. Okay, so I'm gonna just write this out as x plus 2.5 squared. Now remember, we have to take this because this part is actually not part of the graph or not part of the area, right? So let me see, I'm gonna just color these guys in so you can kind of see the visual of it. I like the different colors. And this guy right here, this is the x squared. This is all we need. So the white part is actually the part that we don't want. Okay, so we gotta factor that out, or we gotta subtract it out. So this part right here that we're taking out, right? So we gotta subtract. What is that gonna be? And some people will say 5, and it is not 5, right? Remember, it's gonna be 2.5 times 2.5. So this is actually 2.5 times 2.5. Actually, I'm not gonna do that. I'm going to just go 2.5 squared. Okay, so if you don't know what that is, if you don't know your 2.5s, then you go, it's just put it in your calculator, right? But it is going to be 6.25. Okay. If you have 25 quarters, how much you got? $6.25. That's how I like to think about it. All right, so that's what that is. Okay, and that's exactly what we got here. So again, some people were thinking about asking about in class, well, how do we get the 2.5? Remember, we're just dividing it by 2, if you want to think about it that way. All right, and we're going to move on. We're going to go to the next page. Yep, skip that page. We're going to go to now 4.4. Okay, and I think in one of the classes we did not go over some of these corrections, but the book actually does have a few wrong parts into it. So if right here where it says isolate, change that expression to x squared plus 10x. That's what it should be. I think they copied and pasted wrong. Oops. All right, so we're going to be doing this. And if you notice this equation, this is exactly the equation that we did for the do now. Okay, this is the same one, right? Now we're going to actually get those roots. Okay, so remember I told you to remember those numbers, like put them in your back burner, right? This is what we're going to do. All right, so the first step is, right, what we have here. So we just wrote it down. And what we want, just like how we did for the other one, we want just this x squared plus 10x part. Okay, that's all we want. So how do we get rid of that 12? Pretend that you can't see the minus 12 underneath. All right, so yes, you're going to subtract 12 on both sides so that we can get rid of that part. So it looks like how we've been doing where we're trying to complete the square. All right, so we subtracted 12 on both sides. And so I think this part I'm going to have to show you again. I'm going to just write it again on the right-hand side. Okay, so you could follow along with what I'm doing, because you won't really understand it unless you see what I'm doing, like visually. So I put a space there for a reason, okay? And that's gonna be negative 12 on this side. Okay, so far so good? All right, so this is what I call setting up the perfect square. So we're gonna set it up. So we got, remember we normally have parentheses, we have a square out there, that's an X, right? So this is what we want. Oh, I should put an equal sign, right? We need that. Now, we use a different color, all right? And so what we're gonna do is, remember how we got that middle, that number over here? What do? We use that middle number, right? And we're gonna take that 10x, and we're gonna take it apart, put it into 2, right? So that should be 5, right? So we're just dividing that by 2. So that's gonna be plus 5. Actually, you know what I'm gonna do? I'm gonna put a little room here and give myself a lot of room. So I'm just gonna go a little bit lower here. So this is gonna be x. All right, now I'm going to do it. So we're going to go, well, this is plus 5, right? And then remember how, now before, remember we subtracted it out. This one, we're going to just multiply it all the way out. So what would that be? If we were to complete that square, that corner amount, how much would that be? That would be 25, right? So here we're going to just put the plus 25 here. That would be what the area would be if we included that little square, right? But we can't just include an area on the left-hand side and just let it be. It's no longer equal, right? So how do we make that equal? Well, you can be like, well, you can subtract 25 to make it equal. Well, we can, but what we're gonna do is something else. We're gonna just add 25 to the other side. Okay, so we're just gonna keep that equal. So if we're adding 25 to the left, we're gonna just add 25 to the right to keep that equal. And why do we do that? For this reason. So if we look over here on the right-hand side, negative 12 plus 25, that's going to be 13. Okay, and we're not done yet. Okay, but I'm going to review what we just did. All right, so how do we get the first one? So remember what we did was after we set up the perfect square, right? This perfect square, we took this and we divided that by 2. That's division, divide by 2. And then what do? We do something what I call square up. Okay, so it's going to say square up. Why? Because we're going to square this number and we're going to put it up here. Okay, that's why I call it square up. I do not mean to fight. It's not a fighting word. Okay, so that's so we're going to take this number, we're going to square it up. Okay, and then from there, remember to keep it even, right? We have to add to the other side to keep that even. All right, add to the other side. So first we're going to divide, right? That's how we get that number on the bottom. Then we're going to square up. Then we're going to add it to the other side. Okay, whatever we're adding here on the left, we have to add to the right. Okay, to keep it balanced. Okay, it's always about balance. Math, balance. Okay, they are a thing. All right, and then we're just going to simplify that. Okay, so now from here, remember the whole point of this. You're like, what was the whole point of this? Oh yeah, we got to find the roots, right? So we need to figure out what x is. So now we have just one x. Right, to see this 1x, and notice before it we had 2 x's, right? So like we couldn't solve this guy and it was not factorable. So we're like, I don't know what to do, right? So here we go. Let's solve for this guy. And this is going to be the same no matter what you do. Whenever you're completing the square, this is always the same. I'm just going to recopy this so that that doesn't get messed up, like our steps and all that kind of stuff. All right, and then so what we're going to do is, do we get rid of the +5 or the square, right? And we're like, reverse order of operations. So we got, well, okay, it's actually not reverse then, is it? Anyways, we got to get rid of that square first before we get rid of the plus or minus. So we're going to go boom, square root it, right? So then our answer is going to be x plus 5 is equal to square root of 13. If you've been in class, you know, wait, Miss Lee, you forgot plus or minus. But did I forget? All right, and we're almost there. So what we need to do is now get rid of this +5. And you were like, oh, we've done this since algebra 1, maybe since middle school. I don't know. All right. So here we go. This is going to be x is equal to, and the way we're going to write this, because 5, we cannot add 5 and square root of 13 because they're, one's in a radical and one is not. So you cannot add them together. That is not addable. Okay. I don't know if that's a word, but that's now a word. It's not addable. All right. So this is literally our answer. We're done. Okay, I guess I could have just showed you here. So, oh, like it's the same thing, yay. So another way you can write that is literally -5 plus square root of 13, and then -5 minus square root of 13. Those would be your answers, okay? This is not 4 answers. This is an answer. So this is an answer. This is one answer. This is the second answer, okay? And so, and then you would actually put that in your calculator. And if you did not do it during class time and you didn't listen to what I was saying, do it now. Like literally take your calculator or take Desmos, put it in the calculator, okay? And Desmos, remember, you could use it as a calculator and then do it. Okay? And if you're like, Miss Lee, I don't remember how to do that. Okay, let me just show you really quick one more time. See, I was doing that with some people here. So remember, you don't always have to graph here. You could actually use it as a calculator. So if you don't have a calculator that writes it out, or if you have an iPhone and the iPhone, the bad thing about iPhones is they don't type it all out. So it gets confusing and complicated, okay? So what you're literally gonna do is you're gonna go minus or -5 plus square root is gonna be right here, okay? Square root of, what is it, 13, 1, 3. Look, calculator, okay? It's amazing. Okay, so use this, okay? Don't use the graphing feature on the test because I'm asking you not to do that, right? But if you can resist the temptation, then use Desmos as your calculator. It's really useful. Plus SBA, they use Desmos. So they use this as the calculated portion of it. So yep, and if you look right here, we rounded that exactly correct. And then you do the same thing for the second one, -5 minus square root of 5. Yep, there we go. I don't even have to push enter. Oh, because it's not 5. That's why you always check. 13, I mean. There we go. -8.606. You notice it says 5 here, but remember, if you look right next to it to the right, it's 5 or greater, which means that it's closer to 6 than it is to 4. Than it is to 5, not 4. Bad rounding. Okay. So yeah, so there we go. So it's -8.606. Okay. So please make sure you try that on the calculator. Okay. on Desmos, on your regular calculator, on your phone calculator, whatever it is. And if you need help, ask me, all right? Or ask your friend, whoever. All right, and if you notice right here, this was the other mistake. That was not the right roots. They have the right roots here, right? But they just didn't write it well here. So just make sure you write it in here. And if you notice, they rounded it to the nearest hundredths place instead of thousandths place, which is fine as long as you round correctly, okay? All right, moving on to the next one. And we're gonna look at the next page, number 1. All we did was just find the roots, just like how we've been doing, right? So I'm not gonna do this separately. I'm just gonna show you on here. So remember the first step. And if you did not do this by yourself, go do this by yourself. Press pause. Okay, did you do it? You better have done it. All right, and then all you're gonna do is go minus, remember take out the 10. Well, I guess before that, you have to set it equal to 0, right? Like that's the first step, is set it equal to 0, right? Then subtract out that number, right? So subtract out the 10, and then now you have just these two there, the x squared plus 8x, right? Now we're gonna set up the perfect square, right? Okay, and if you guys need, okay, so first step, right? Set equation equal to 0. Right, and then second step, right, was subtract or shall we say, or add out. I guess not necessarily subtract, it could be subtract or add, right? So how do we say it? Put the constant on the other side, maybe that. Okay, so that's where we did the subtract 10 on both sides, right? So this is like this is my first step that I did, this is my second step that I did. Okay, we kind of match it along with here. And then what do we do? We're going to set up the perfect square. Okay, remember we're going to do the parentheses with the x and the square and the equal sign. That's what I'm calling setting up the perfect square. So we set that up. Do you see how we did that in black? That's what I did in those 2 different colors. All right. So this is like our third step that we do right here, right? And then we're going to do some stuff. What are we going to do? So it's going to be, we're going to, remember this was called b. So we're going to half b. In other words, b divided by 2. And then what are we going to do? We're going to square up. And then what are we going to do? And we're going to add to the other side. So what does that mean? So literally we're going to, so this whole section right here is 4, right? So we're going to half b, so this is b right here. So 8 divided by 2 is 4. Then we're going to square up, so square 4 and then put it up here, right? So 4 squared is 16. And then we're going to add it to the other side, literally to the other side. Okay, so if we added 16 to the left, we add 16 to the right, okay? And then all you need to do from here is to solve for x. Okay, and what is this whole thing? Using completing the square. To find the roots. This is one of my favorite things to do. I have a lot of favorite things to do. This is one of them. I really enjoy doing that. Okay, and if you remember, how do we solve that? So this is right here. This is going to be our step 5. This is how we solve. Always use square root first, right? And then you're going to, remember, don't forget the plus or minus. And then you're going to subtract or add out whatever this number is, okay? And then there's your answer right there. If I usually want an exact answer. If you answer just like that, that's fine. If you need to graph it, please actually, you need to put it in a calculator, because like where on the graph is -4 plus square root of 6? I don't know. right? So give me an actual number that I can relate to, right? So if we plug that into the calculator, that's going to be at negative 1.55, and that's going to be at negative 6.45, which looks about right. So we're good. Okay, that's a good check. All right, so here we go. We're going to do the same thing here. So if you did not do A and B, I would recommend that you do A and B, right? Take this time to figure that out. Just pause. Don't look at the answers. And then you could take a look, right? So I would make sure that you're following these steps, right? If you have these step downs, my hint is, you know, if you have like a notes page, like I would copy those down, right? Put them in your book. I don't know, wherever you put your notes. If you have a notebook, have a notebook, right? And write those down, okay? And I would put these numbers right next to them, like an example. I would have an example on one side and then like put down those numbers though, like where, so that they line up, so it makes sense. All right. There we go. So there's that. Try these ones out. Okay, now we're going to change it to vertex form. So we're writing the quadratic from standard form to vertex form. Okay, so we're going to skip this part here because this is in a very symbolic way, but we're not going to do the symbolic way. We're going to just do it the other way because it gets weird. So here we go. I should erase all this, I guess, but I'm going to go with another period where we didn't do this part. Just so that I can show you guys. Oh, we got to all of them. All right, never mind. Let me do this one then. Okay, we'll try this one. Okay, so we said here, it says rewrite each quadratic equation in vertex form, right? And so we have this equation right here. And the only difference about this guy, so I'm going to just redo this again just so that I can show you guys. I'm just going to put it over here on the right-hand side. Let me make this black as well. So this is going to be y is equal to x squared plus 8x minus 9. We're going to do it a little bit different, but it's pretty much the same idea. Okay, same concepts, same principles. Okay, so we want to leave this, the y by itself. Okay, we don't want to touch the y. We want to leave y by itself because we want the equation, right? So always in vertex form, the y is just by itself. All right, so this is what we're going to do. So we can't just like add 9 to both sides or have this equal to 0. Like that's not going to work out because we want to keep y, right? So what we're going to do is we're going to like put that 9 over there, right? So we're going to be like, okay, y is equal to x squared plus 8x. This is the part we're going to make into a perfect square. And we're going to put the minus 9 over there. Social distancing, right? Gotta leave that away, right? And so then what we're going to do here is, again, we're going to set up the perfect square. Got my parentheses, I got my equals y. Okay, so now we set it up. We use my other color. If you need to use another color, use another color. All right. And then what we're going to do here, remember, we're going to, what did it say again? Let's go back. What did it say? It said something. Oh, it was far way back. Oh, wait, it's not here. We're going to write it on here. Then I hope you remember. What were we supposed to do again? Yes, you're going to half b, right? So we're going to take half of 8. We're going to go, so this is going to be plus 4. Then we're going to square up, right? So we're going to take 4, we're going to add it, 16. Okay, so this is my perfect square right here. So I want to leave this part alone. This is my perfect square here. I probably should have done it with the other color. Maybe I'll do it with the other color to keep that consistent. Okay, so this, my perfect square. All right, so I don't really want to touch that. All right, so then what I'm going to do is, you're headed this color. So I just added 16 to one side. And normally I would add 16 to the left-hand side, but I don't want to touch y. I want to leave y by itself. So what is another way I could do that? What, like, how can I still keep it equal, right? So what we're going to do is we're going to actually just subtract 16. Okay, if I add 16 and subtract 16 on the same side, I essentially just added 0. I added nothing, right? I didn't do anything to the value, right? So if I give you $5 and I take away $5, does your bank account change? No, nothing happens, right? But you might be concerned as to why I'm putting and taking out money from your account. All right, so then we're just going to add these guys up, and this is going to be minus 25, right? Because negative 9 minus 16 is minus 25. We're done. That's it. No other step. I know, crazy. So just so that you know, so this part right here, belongs to this part right here. And so this is now vertex form. This is what we wanted. Yay, happy days. Vertex form. So what does that tell us? So we're going to go back here. Remember, this part right here inside the parentheses tells us the AOS, right? The AOS is not going to be +4. It is going to be -4. Remember? Because remember that is normally a negative. So I wrote down the thing right here. So this is normally a negative, which means that how did it become a positive? The only way it became a positive if this number right here was a -4. Okay, so that's why AOS is equal to -4. And here we drew that in right here on the left-hand side. And then we also know that the vertex, right, because this vertex form, therefore giving us the vertex, is -4, -25. So this one is that, this guy is that. That's where those numbers are coming from, okay? That's vertex. So we drew in the vertex right there. Where did I get this -9 from? Definitely not from the vertex form. If you remember, oh yeah, we had a standard form, right? And that last number right there, if we plug in a 0 for the x's, we just get y is equal to -9. That is our y-intercept. Well, how did I get this other point? Remember, reflecting across the axis of symmetry. So we know that exact same point with the same distance is over here. Yep, that's the thing. So then what are our roots exactly? It looks like it's going to be close to 0 and another one's going to be kind of far away from 0. How can we find that out? Like, Miss Lee, we've been doing that this whole time. I'm like, you're right. Remember, so we're just going to set this, instead of setting the standard form into 0 equal to 0 and then completing the square this way, we already completed the square, right? Let's just use this one. So we're just going to go 0 is equal to x plus 4 squared minus 25. Let's just solve for it, okay? So what's the first thing we need to do? Don't say square root, because we can't. Well, we can, but it's going to be super complicated. So we're going to just get rid of this part first. So we're going to add 25 to both sides. And then what do we have left? So we have 25 is equal to x plus 4 squared. Now we can do what we've been doing, right? So we're going to just square root both sides. And then we're going to get x plus 4 is equal to plus or minus 5. Did you forget the plus or minus 5? All right, and then we're going to do, we're almost there. X is almost by itself. We're going to just subtract 4 on both sides, right? So then we get x is equal to -4 plus or minus 5. If you leave your answer like this, I will not be happy with you. This is not okay. You just need to finish it. All right, because this is not a square root. You can actually find a number. Okay, so x is equal to, I'm just going to write it out, -4 plus 5 and -4 minus 5. Those are the two numbers, okay? So we're just going to simplify it. Just don't leave it like that, because we can actually simplify this. Remember, if you can simplify, always simplify. So -1 plus 5, -4 plus 5, that's going to be 1. -4 minus 5, that's going to be -9. If you leave it like this, but you're like, Miss Lee, that's not written as a point, that'll be fine. I think I'm at the point where you guys understand that this is a point, okay? Because there are people that still didn't understand that that was a point. So for our roots, so this was our roots work right here. So this is our roots. So we go back to our roots at 1 and -9. So if you notice right here, this is 1. So yep. See how it was close to 0? This one is -9. Yep. There we go. We did a pretty good job. All right. Just when you started, you think you got it all, they throw you a question like this, number 2. Like, what is this? Okay. So we're going to do this one. I'm going to get some room here. I need some more room. While I can erase this guy, well, I'll just erase it because you guys have the video of it. So we'll just go with that. Unless you don't want to. Yeah, I'm just going to erase it. Bye, guys. Just look on the video. It's no longer here. No trace of it to be found. So sad. Okay. So actually, I just leave that other part there because we went over that class. So let's try this guy right here. So we're going to do b. Now, what if you have a coefficient for x squared, like a is not equal to 1? Then we went into, okay, we don't run into that much trouble, but it's a little bit crazy, but it's okay. Why they made us work with fractions, I don't know, but that's what we're going to do. It's good for you guys to see fractions because life is fractions. If you like music, you like fractions. Just gonna tell you that right now. Well, don't disavow music because of that though. So what we're gonna do here is we're gonna do the same kind of thing. We're gonna kind of make that -1 or -1 be kind of far away, social distance that. Right, they're not part of our family. All right, so here's 2x, and there's that -1. Okay, the thing that you have to do is that this has to just be x. Like when we set up the perfect square, that doesn't have a number, it's just x, right? So what we're gonna do is we're gonna have to factor out that 3, okay? So y is equal to 3 factored out, right? Factor out that 3, x squared. And some of you guys be like, well, Miss Lee, 2, 3, not there, that doesn't go out, right? It doesn't work out. But remember what I said, right? So remember, or as somebody else said, if is factoring out a 3 is like dividing this by 3, right? So literally we're just going to divide that by 3. Don't forget that -1 out there. So yep, it's just going to look like that. So now remember, if we distribute it back in, it should look like the thing on top. So 3 times x squared, yep, 3x squared. 3 times 2/3 x, right? The 3 and this bottom 3 here cancel out, become a 1, right? And that's going to be just 2x. So we're good. It's confusing, but it's good. And now, again, we're going to set up the perfect square. So here we go. We're going to set this up. X, and this is square. And don't forget that 3 on the outside because that's, you know, just part of the equation. And then now, okay, we set it up. So now, what do we do first? Half b. What in the world is half of 2/3, right? We've got 2/3, take that in half, a third here and a third here, right? Or if you want to think about it, 2/3 times 1/2, right? Because 1/2 times 1/2 is the same thing as divide by 2. That's the same thing as 2/6, which is equal to 1/3. Or if you like want to just cancel that out, those become 1s, multiply straight across, that'd be 1/3. Same thing. All right. So this is going to be, so halved it, and that's going to be 1/3. Now we're going to square up, right? So 1/3 times 1/3 is 1/9. So it's going to be plus 1/9. And some of you guys will be like, okay, then we're going to just subtract 1/9 here. And you'll be very wrong, right? Because we didn't just add 1/9. What did we actually do? We have to multiply this 3 times the 1/9 because we actually have 3 1/9, right? So we're going to have to do that. So it's going to be 3 times 1/9. And what is that going to equal? Remember, that's like over 1. So it's going to be 3/9, or AKA 1/3. So we actually just added a third, not a 9th, okay, because of that 3 on the outside. So that's the one step that you do need to remember. People will forget that. All right, so if we added 1/3, we're actually going to have to subtract 1/3 out here, right, to keep it balanced, because we don't want to add on the other side. Okay, we want to keep that y as a y. So what is that going to be? Negative 1 1/3, or I like to keep that as a mixed fraction, improper fraction. So it's going to be that. And we're done. It wasn't terrible, right? You might want to rewind that if you need to rewatch that. So our vertex is going to be negative 1/3, right? It's opposite of what we're seeing there. And then negative 4/3. If you want to write in here negative 1 1/3, that's fine. Okay. And we're going to just check it on the graph just to verify, because some of that looks, I don't know, right? Just to make sure that we did that right, because that is fractions and you never know about fractions, right? Y equals 3x squared plus 2x minus 1. And that should give us those roots. So I'm going to just zoom in just a little bit here. And if you look at, oh, no, not the roots. That's our vertex. Sorry. And if you look at a vertex, negative 1/3, because remember 0.33333 is 1/3, right? So negative 1/3, which is what we got for the x, and for the y is negative 1 1/3. Same thing. You see, same thing. It's okay, right? And then we could go again and find the roots. Notice the roots. Okay, they're not terrible. So let's go find the roots then. So we're gonna graph this guy, and so this is our AOS. So this is a vertex. See, this is what happens when you don't label. Vertex AOS is going to be x is equal to negative 1/3. So, oh shoot. So let's make this like 1, or I should say negative 1. So negative 1/3 is going to be like a third of that. So like right about here. Okay, so this AOS is x is equal to negative 1/3. Okay, and then my vertex is going to be negative 1/3. So it's on here and 1 1/3. So if I'm making this about the same length, so that's negative 1. So like negative 1 1/3 is like right about there. That's going to be my vertex. What is my y-intercept? Remember, it's right here, right? Is in standard form, not in vertex form. Vertex form, that's not the y-intercept, right? So yep, it's right here at really close to the vertex, right? And so remember, on the other side, about the same distance away, that's going to be your other, what is it called? Other point, right? Reflected. Okay, now we're just going to find the roots. I don't want to put in the roots just yet. Okay, so we're going to find out what they are. So remember, we're just going to use it in vertex. Where's my vertex form? Oh, there it is, right here. So we're going to use this vertex form right here to solve for x. So we're going to put 0 for y because we're looking for the roots, right? Y is equal to 0. So 3 times x plus 1/3 squared minus 4/3. Okay, so first things first. We got to get rid of this minus 4/3, right? So we're going to just add 4/3 to both sides. So add 4/3. And what do we get? Oh, these are bad lines. Okay, so this is going to be 4/3 equals 3. And then this is going to be times x plus 1/3 squared. That should be a divide. All right, and then from here, we're not square rooting just yet because we got to get rid of this 3. Okay, so we're going to get rid of this 3 by just dividing by 3. And instead of dividing this whole thing by 3, what I'm going to do is just times it by 1/3, right? Because dividing by 3 is the same thing as multiplying by 1/3. Okay, if you didn't know that, now you do. That's a thing, right? That's probably the easiest way to go about this. So we're going to go, well, this, if we multiply straight across, this is going to be 4/9 is equal to, now the 3's cancel out, so all I have left is x plus 1/3. Stay with me. I know fractions, usually like kids' eyes just glaze over and you're just like, all right, so we're almost there. So now we have this square by itself in the parentheses, nothing else there. We're just going to now square root. Both sides, boom, boom. Don't forget your plus minus, right? And then we have x plus 1/3 is equal to, oh, we know the square root of 4. That's 2. What's the square root of 9? That's 3. We're going to go plus or minus. And then we're now going to just subtract 1/3 on both sides. So what do we have? Sorry, I don't know why it's so crooked. You're going to have to look like this. You're getting a crick in your neck. And so that's just going to be negative 1/3 plus or minus 2/3. All right, so negative 1/3 minus 2/3, that's going to be 1/3. Negative 1/3 minus 2/3, that's going to be negative 1. Don't believe me? Check on your calculator. So that's exactly what we had said, right? So 1/3 and negative 1. So if we go back up here, negative 1 is right here. And that's going to be, and then about 1/3 is like right about there, right? So we're going to a parabola. Yay, that one actually doesn't look so bad. Okay, and that's what that's going to look like. So now we know exactly where those roots are. We know how to find the vertex. We know how to find the AOS. Y-intercept we already knew how to do. All right, so that's how you make a very accurate graph. I may not have drawn it very accurate, but at least the points are accurate. Good okies. All right, so I said go try the talk the talk, right? Talk the talk is like, can you walk the walk, talk the talk kind of thing, right? So if you didn't do this yet, do it. I'll wait for you. Okay, you can just pause it. I'm not gonna wait for you. I'm not gonna have like silence for like 3 minutes, too much. So consider the equation, quadratic equation y equals x squared minus 4x minus 5. Okay, rewrite the equation in factored form and vertex form. So we're gonna do it in 2. So we already know right now, if this is telling us to write in factored form, it should be factorable. And then we're also going to write in vertex form. So we're going to kind of combine all the things that we've learned. Okay, this is a great question, right? So first thing we're going to try to write it in factored form. So y is equal to x squared minus, I just always like to copy it down. And then remember, we're going to do our 1 and 1 because that's the coefficient is 1. So 1 times 1 is 1. So what times what is 5? Well, you only have one option, 1 and 5. So hopefully that works, or else we're in big trouble. All right, so remember that this is negative 5, which means that one of these guys have to be negative. Well, we're not there yet. So 1 times 1 is 1. 1 times 5 is 5. So I want this to be equal to a -4. So how do I do that? Well, it's got to be a -5 then. Don't forget to then change it over here. That's super important, or else you can change it here all you want, doesn't matter, because then your equation is still going to be wrong because you didn't have that, you didn't change the actual number, right? So this is going to be -4. So we're good here. So this guy, we're going to make that pink. So this guy is the same thing as this guy. So that's a good day. So remember, we're going to go straight across. And we're going to go straight across. If you guys have highlighters, totally use them. Okay. The visual markings, the colors help your brain to remember stuff. Okay. And then so here we go. We're going to go straight across and go x. Remember, because the 1 was a coefficient of the x. So x plus 1. And this is going to be x minus 5. Don't forget your y. So now this is factored form. And remember, from the factored form, what do we know? The roots. All right, so now we're going to try this in vertex form. So this is going to be x squared minus 4x minus 5. Remember, we're going to like social distance that minus 5, right? So we're going to go, well, we don't need you just yet. So x squared minus 4x, then over here, minus 5. Now remember, what do we do? Set up the perfect square. So setting that up, here's the y equals. Good thing there's no coefficient there, u, right? So then remember what we do, right? We're going to half b, so half of -4, which is going to be -2. We're going to square up, so -2 squared is -2 times -2, which is +4, right? And then don't forget to, since we added 4, and we can't add 4 to the left-hand side, we're just going to subtract 4, okay? So adding 4, subtracting 4 on the same side makes that cancel out, okay? And then, but then we're going to be able to get -5 minus 4 is going to be -9. And if you guys take a look right here, let me make this into a different color, yellow. Let's go yellow. So this guy represents this guy right here. And let's change this to a different color, like purple. And this right here represents this part right here. So that's why they're separate. You're not going to add up the 4 plus 4 minus the 5 minus the 4. That doesn't make any sense. Okay, this 4, the +4 goes with that perfect square. Remember that little part there that we were missing? And we're just going to take that. We're going to add it in, but then we're going to take it out in that purple section right here. Okay, so it actually, it's not there. Oh, it's just 0. So now we have it in vertex form. Yay. So we have both forms right here. So this is factored form. And this is vertex form. And this right here, you guys remember, is standard form. Or we could say general form. The book likes to call it general form. That's okay. All right, so now it says we're going to graph the function. Identify the vertex, the x and y intercepts, and the axis of symmetry. Then explain how these are evident in each of the each form of the equation. Well, we're just going to take those things from here. So remember, in the standard form, what do we know really well? Like, what's super easy to see? The y-intercept, right? So I'm just going to be like circle y-intercept. Okay. Then we're going to just put the y-intercept at -5. So 1, 2, 3, 4, 5. If your graph is not labeled, just make sure you at least label 1 point on the x and y axes so that we know like what your units are. So there we go. That's a -5 y-intercept. Good. Check. Okay. From factor form, what do we know? Well, we know the roots, right? I'm going to write on here the roots. Excuse me. Remember, it's opposite of what we see. So x is equal to, right here, -1 and +5, right? So our roots are going to be at -1 and +5. 1, 2, 3, 4, 5. Just going to write that as a 5. Sorry, I need water. All right, so then from here, so that's what my roots tell me. Now it looks kind of lopsided, right? It doesn't look like, but we don't have an AOS, we don't have the vertex yet. So we're gonna get that from the vertex form. So remember this one, this guy right, oop, hello. There we go. This guy right here tells us the AOS. So the AOS is going to be x is equal to 2. Remember, it's the opposite of what we see. Whenever it's in those parentheses, it's the opposite of what we see. Just like in the parentheses for the factored form, it's the opposite of what we see. So remember here it says +5, +1. So we have wrote down -1 for the root. And -5, that's +5. If you want to set them equal to 0, you can do that. Okay, so then our AOS is 2. So we're just gonna go 1, 2. So, oh, did not mean that. So this is going to be our AOS. So this is our AOS. And then our vertex, right? Remember, it's called vertex form, right? That's going to be these two guys. So it's this guy right here and this guy right here. So is it going to be 2, -9? Okay, so that's going to be 2. And you need to scroll down just a little bit. So that's -5, 6, 7, 8, 9 right here. That's going to be our vertex. Okay, so remember on the y-axis, we have the y-intercept. We do have that reflected point, so that's just going to help me draw it a little bit better. So it's 2 away from the AOS. I'm just getting 2 away on the other side, and that's going to be your point right there. So I'm just going to draw it now as best as I can, just like that. Okay, so remember, from the roots, what do we know with the roots? Or factored form, we know the roots. From the vertex form, we know the vertex and the AOS, right? And then from the standard form, we're getting the y-intercept, okay? These are the things, the characteristics that we can find from each of those things. Does it mean that if we have standard form, do we need to convert it in these two forms? No, you don't need to. Because once you get to vertex form, or in standard form, you can find the AOS how? By doing the, remember the x equals -b/2a? Right, this is how we found the AOS. And you just plug it into the equation to find the vertex. Totally do it that way. You don't have to change it to vertex form, right? The only thing is with the roots, right? So with the roots, if you can't factor it, then you're just gonna have to use completing the square until Thursday when we learn about more stuff. Okay, there's gonna be, but it's all related to completing the square, right? But they actually did one in general form with completing the square, and if you don't know it, we will know it on Thursday. Stay tuned. All right, let's see here. Oh, so that's the end. So remember, our homework is going to be number 4 and 5. Please make sure you try those out. Check it on, check the answers in Canvas. All right, and there we go. Have a good one, guys. Bye-bye.